Oh, now you're muted.
We'll go ahead and start the talk. So, and for today's speaker, we actually have Dr. Bridget Scanlon to do the introductions, and so I'll turn it over to Bridget.
Thanks, Brian. We're delighted to have Rick Kropp give us a presentation today on integrated water resources in Northwest Kenya, Turkana and Marsabit counties. And Rick served as the director of the USGS Water Resources Science Center in New Jersey from 2002 to 2021. And this center conducts water resources research and investigations and collects groundwater and surface water quality throughout New Jersey. He is currently USGS Emeritus and continues to work with USAID and World Bank on water resource projects in Kenya, Ethiopia, India, and Panama. And prior to USGS, Rick served as New Jersey Department of Environmental Protection from 1980 to 2002 as the Bureau Chief of State Water Allocation, Well Drilling and Regulation. And he also worked on coastal issues, freshwater wetlands, floodplains in New Jersey. Rick has a bachelor's and master's in civil engineering from Villanova University and is a graduate of the Federal Executive Institute and earned his professional engineering license in New Jersey and Pennsylvania. So thank you so much, Rick, for giving us a presentation today, and really looking forward to it.
Sure. Glad to be able to do it. So do you want me to pull up the PowerPoint now and we'll share the screen? Okay, well, welcome. Glad to have this opportunity today. This is a project that started about 5 or 6 years ago. Initially started as a project in both Kenya and Ethiopia. The work in Ethiopia is on hold right now because of some of the issues there, and we've been focusing our efforts on Kenya. After we first met with the folks in Kenya, they thought that these two counties were the areas that they would like us to focus on with this first phase of the project. And so we're talking about Turkana and Marsabit counties. These are up on the northern part of Kenya, right along the border. So here's a little outline. I'll give you a little background on the personnel involved with the project, what the objectives of the project are, what our approach has been using remote sensing, hydrogeology. We do economic assessments, capacity building, talk a little bit about the study area, give you some idea on the results, and then we'll have an overall summary on the project. And if you have questions as we're going along, you want to bring them up, let me know, and we'll see if we can answer them as we go, or you can hold them to the end. It'll be your choice. So the customer for this project is USAID, right? The United States Agency for International Development. We're working with folks out of the Kenya mission. Amanda Robertson and Martin Malango are our two main contacts there and have been since the beginning. Very supportive of the project and have been a real help to us in making connections with other folks that are working there. So I'm kind of the project lead right now. I'm now with the Office of International Programs. I'm no longer with the New Jersey office. I'm joined by Saud Amir, who is a remote sensing specialist out of the Office of International Programs. Tom Mack is also with the International Programs. Tom has been helping us with some various instruments that he's found that we've been able to use that are passive seismic units that help us kind of map some of the subsurface in that area. Wayne Belcher is the hydrogeologist on this project. As I mentioned earlier, he's out of our Nevada Water Science Center, and because of his background with the hydrology of arid areas, we brought him in because this is a very arid area and he's got a really strong background there. We have an office in Flagstaff called the Astrogeology Office. These are the folks at USGS that work with the JPL and NASA and identifying the geology of other than Earth. And so while I was there one time, I asked if they were the ones telling NASA if there was water on Mars, and they said yes. And I said, well, can you tell me if there's water in Kenya and Ethiopia? And they said, we think we can. So I said, all right. And we added them to the team. They've been a big help. Pat Chavez did work there. He's a retired USGS employee, but now he works at Northern Arizona University. And him and Scott Kelly have been doing most of the grunt work on the remote sensing. And we also have Frank Ward from the New Mexico State University that's helping us with developing an economic optimization model that we'll talk about a little bit now. So the objectives of the project were basically to assist the government of Ethiopia and government of Kenya in exploring and mapping groundwater potential. And the idea was once we had proof of concept that we could do this, then we would be repeating it in other areas of Africa as needed. The idea, and this really lines up with USAID's goals, and that is to increase the household resiliency to drought and related shocks by increasing access to water resources, and in this case, groundwater. And we want to build the local capacity. So this idea of us coming in and doing the work, demonstrating what can be done, and then helping them to do it on their own, so that we don't need to be there anymore. They can continue this work without us. And that's really one of the major goals of USAID, is building internal capacity. So our work plan is basically set up this way. We have a couple of different components: the remote sensing component, the hydrogeologic model that's been put together, the economic optimization model, and then we come out with the products that we'll show you. And then component D is to take everything that we're doing and helping to the folks there understand how to do it and let them replicate the work so that they can continue the work after we're gone. So these are the two study areas. So we're looking on the left at southern Turkana, and why we say southern Turkana, because the northern part of Turkana had already been mapped by RTI, which is a French firm that does very similar work. So they wanted us to focus on the southern part of the county. These are either side of Lake Turkana. And then Marsabit, which is on the right-hand side there. These are the two counties, and you can see from the maps below where they located within Kenya. This is what it looks like there. This is very, this is a desert. It is really, really dry. This is the Turkana River that runs through Lodwar. It is bone dry, and if you can see in the background there, there's actually people digging in the riverbed trying to find water. That's how desperate the situation has gotten out here in some of the areas. So component A is the remote sensing technology. And if you have any specific questions on the type of remote sensing we use and stuff, I'm probably going to defer that to the folks, Saud and Pat, to answer those questions later, and I can hook you up with them. I have kind of an overview of it, that mile wide, inch deep type of approach. So we wanted to acquire and calibrate the remote sensing. We were looking at what RTI did and was saying, could we replicate that and do it with freely available data? One of the concerns that starting this project is RTI has done some very good work, but a lot of their stuff is proprietary. So we wanted to do this. It was all open source, make sure that we're using data sets that are available to the folks in Kenya and elsewhere. And also that any software we're going to be using for it is either free or is very freely available. So we're trying to identify not only the aquifers and where the groundwater is, but also the recharge zones. There was an interest in a little bit more land use planning there to try to protect these. So we've been identifying both potential groundwater and potential infiltration areas. After the maps are developed, we put the maps on these GWENs. Okay, this is a groundwater unit that we take out in the field, that they know where they are relative to the map. They're GPS enabled, and we just had the training. This is what Soward and Wayne were over there in June, was to take them out with these GWENs units, which are basically laptops, and showing them how to use them so that they know when they're drilling exactly where they are relative to the map. One of the concerns that was raised very early and got this project started is that the well drilling activities in this area have about a 20 to 30% success rate of hitting water. Drilling is very expensive and in some cases dangerous. As you know, 24/7, you've got to drill, and sometimes there's not a safe area around there. So when you are drilling, you want to make sure you're hitting water, obviously. Where maps like this have been developed in the past by USGS, and they've used the maps, they can get up to 80, 90% success rates by using those wells. And that's really what that last slide is. We want to see an increase in the rate of drilling water wells. So again, we're going to go back. This is Turkana. Again, we're going to be looking at the sub areas, and the PGW is potential groundwater, and then PI is potential infiltration. So if you look at the legend down below, we've kind of put these into three categories in both cases. A high potential for groundwater, a medium potential, and then low, and the same thing for infiltration, high, medium, and low. If we kind of zoom in a little bit, you can see, again, this is desert. We're not going to find a lot of water. So the areas that we find tend to be following, riverbeds and wadis and areas when they do get rain and they get some infiltration. There's been work done in the past by Meisner and others that said if you can look at some of the vegetation out there, especially the phreatophytes and the xerophytes, that's an indication that there's access to groundwater. If you're in a desert area and you're seeing some woody vegetation or some vegetation that's surviving through the drought periods, these things have their roots down into the groundwater. And they've actually been able to show in certain plants, they can actually figure out the depth of groundwater, and in some cases, the water quality. So using the Landsat remote sensing data, we've been trying to identify those areas and then pulling together the other information from the SRTM, which is the shuttle radar topographic mission, to give us information on the topography. And here we'll kind of zero in a little bit, and you can see again, looking at those colors, where we think you're going to find water. Not a lot of areas. Again, we're in the desert. This is very difficult to find water, but there are areas out there we think that have high potential for it. And this is the Marsabit, which is the other county that we're working in. And again, seeing the maps here, again, it's the same type of legend with the high, medium, low, both on the groundwater potential and also on the potential infiltration. So as we zero in, again, we can see the areas in red are the ones that we would be focusing on as far as where we think water is. One of the interesting things too is looking at the road network, because a lot of times there may be areas that we think are high potential, but can they get access to it? These areas that you can get a drilling rig in there. And I think one of the concerns with them having 20 to 30% success rate is they were drilling where they needed the water, not where the water was. Here in the United States, we're going to locate where the best place to put a well is, and then we'll use distribution systems and other ways of moving that water around. They don't have the infrastructure, so they tend to want to drill where they need the water. This is going to take a little bit of a change of drilling where the water actually is and then figuring out a way to move it. And here, mostly that's usually trucks that they're moving the water around in, because they just don't have the infrastructure of pipes and distribution systems. So the next step was to take this remote sensing, because the remote sensing basically is going to help us in the shallow systems. We look at that as the top 200 meters. Can we find something out about the top 200 meters using the remote sensing? Below that, we really, you're not going to see anything down below that, obviously. But we're trying to pull together little pieces of information from all over, kind of a convergence of evidence to where we think the best place is to drill. The hydrogeologic is what we use for basically the 200 down and deeper. And again, here we were relying on well completion reports and geology reports that we picked up from the various groups that we're dealing with over there. There was a real lack of data, and I think that really harmed our chances of really defining the system as much as we could. As I said earlier, we had access to 500 different well completion reports in these two counties, and about 80 of them were actually useful. Some cases they weren't filled out at all. In some cases the locations were bad, and it just really something that we've been talking to them about working on, because each one of those data points, if you wanted to go out and drill wells now, think of how expensive would that be. And if you have access to these and they're not giving you the information they're required to, you're really missing out. So we're going to continue to focus on that, and I'll talk about that a couple of times, of getting back to getting data. We need more data, and they have access. They have ways of getting it through their regulatory programs. It's not been very efficient. So obviously with the hydrogeologic information, we're trying to get some information about flow directions. Wayne's put together some cross sections and putting together a conceptual model, and hopefully coming up with some kind of a water budget, understanding that with the lack of real good data, that's going to be not the best model, but it's going to be the beginning for them and showing them how to continue it. So the idea again of capacity building is to have them understand how to put together these models and what's needed. How can you update these models? One of the things we've stressed from the beginning is this is not a project, this is a process. When you're mapping groundwater, every time you collect new information, you can go in and update the maps. We've been doing this in New Jersey for well over 100 years, and every time we get new well records in, sometimes you find out some information in an area that you didn't know before, and you can refine your mapping. So again, thinking about this, and I think that they've caught on to this now, is that it's not a project. You don't just do the map once and put it up. It's a process that you continue. And as you're going forward, every time you're drilling, we keep saying, even if it's a dry hole, that's good information, because now you know something about where there is no water, not just where there is water. So continue to take the data and use it to be able to update the maps and the models. So the conceptual models were put together. Basically, we picked two areas that were high priority and tried to focus on those when we put together the conceptual model. The challenge here, obviously, is they want to maintain groundwater in a sustainable fashion. And one of the concerns with that is, again, if you don't have good data, it's going to be very hard to do that. And really what we found is basically there's an incomplete, record of information, and it's kind of fragmented. They devolved a lot of the government functions about 5, 6, 7 years ago from the federal level to the county level, and that included a number of functions dealing with water resource management. So there's still kind of a roles and responsibilities game going on as to who's supposed to be doing what, and what's being handled at the federal level, what's being handled at the county level. And so it's kind of fragmented, and a lot of the information that we found out there was outdated. So we talk about a conceptual model and why we would put together a conceptual model, and it's really trying to understand what's going on as far as groundwater occurrence and movement within the system out there. So we talked earlier about what kind of geology is out there. You know, we have alluvium, we have basalt, and we're just trying to find out a little bit. Can we find out something about this? Is groundwater flowing into this valley? Is it flowing out of it? Can we get some ideas on direction? Can we get some information that's going to help them understand as they go ahead and start developing this aquifer, really what's going on in the subsurface? Okay. So again, conceptual models, really to try to understand how the groundwater system works. You know, is it sustainable? That's going to depend on how they pump it. And again, here you see a river. It dries out as soon as, and I'm sure you're used to this out in the West too, where you've got wadis and dry washes. When it rains, they got water in it. When they don't, there's no water in it. So where is it going? Can it be recovered? Is it actually sustainable? Is it subject to contamination? If they start putting wells in, are they going to be drying up some of the surface water systems in the area where they've got springs and others? So trying to bring it all together, and that's why we talk about integrating all the water resources. That surface water and groundwater are obviously connected, especially in the near surface aquifers. So the total study area in this area is about 147,000 kilometers. We've put together a hydrologic framework model. We've got somewhat of a potentiometric map with some water level information that was given to us. And Wayne's tried his best to figure out what's going on down in the deep groundwater. So we've got cross sections through the model at 300 meters, 500 meters, and 1,000 meters below ground surface. So by taking the information he had there, he's trying to put together basically the cross sections that'll be used in the development of the model. This is the hydrogeologic framework model with a little idea of the different types of geologic formations that we're dealing with out there. And that's like Turkana right in the middle. And then the potentiometric map kind of giving an indication of where the water levels are and maybe getting an idea of the direction of flow. So the deep water potential maps, we take again slices through the hydrologic model at different depths. And we're again trying to come back and say, where do we think there might be water? And the alluvium is probably the area where they have the high potential. Some of the volcanics have some moderate potential, as do the sedimentary. The volcanic cones are saying moderate to low, and the base, no, it's just solid rock. There's not really much down there. So let me go back here. So again, the 300 meter, 500 meter, and 1,000 meter cross section. So here we are at 300 meters. And again, you're not going to see a lot of high potential. So there's some medium potential areas here and low potential, but deep groundwater doesn't seem to be really available at this point. There's not a lot of wells drilled down this deep also. So this is another case of not really having very good data. So this is at 500 meters. Again, we're not going to find very much down there. There's some medium potential and there's some low potential, but really no high potential, and definitely down at 1,000 meters. So the next thing is, once they do find water, how are they going to use it? How is it going to be distributed? How is it going to be allocated? How are they going to be able to deal long-term with who uses it and how they use it? So putting together an economic optimization model, this is a way of at least giving them a tool that they could use where they can put in various parameters, and these are all established by them. What's more important? Is it basic water supply? Is it agricultural? You know, you decide what you think are the most important uses of the water, and then the model will help you figure out the best way to distribute that water in a way that meets those objectives. And this is where we bring in New Mexico State. So basically, you know, we're talking about the economic value of water. And basically, some of the things that have to happen, and they are starting to happen over there, is changing some of the laws and who's responsible for what. And that's why I talked about earlier, roles and responsibilities, to making sure that you really understand how it all works together. If you're going to try and manage it, one, you have to measure it. You've got to have metrics. And if you're going to want to maintain it as something that's going to be stable over time, you really have to understand the system. And again, this is an ongoing process, not a project. So as you collect more information, you're going to have, you know, better ways of moving forward. Now, changing some of the regulations, you know, can you put limits on the groundwater pumping once they do find a well? Can you require meters? Can you start getting an idea of water use? How much water use is going on there? If we're going to do models, we really need that kind of basic data. We're fortunate to have run into some folks from the University of Colorado that are putting out vibration sensors on a number of these wells with the idea of some of these wells get drilled and they don't get maintained, and all of a sudden they stop working. So these vibration monitors let them know when the well's running and when it's not running, and they can look at it remotely. Well, if they know what the capacity of the well is and they know how often it's run, we can get some basic water use information. So while it wasn't set up for that, we're looking at it as an opportunity to show them, hey, you can take this information. Again, if you have pump capacity and you know how often it's running, the wells are running, you start to get some idea on water use. So you can start collecting some of that information that'll help you refine your models. So the economic, as you develop it, if you want to conserve it, who gets allocated, who's going to, some of this water needs water quality. We talked about that earlier, that we're going to need some help. They haven't really done much on water quality sampling or analysis, and they're going to need that. And the protection of it. If you're going to be able to keep this as a long-term source of water, you're going to have to understand where the infiltration is coming from and make sure that you're doing something to preserve that, or at least not contaminate it. And as already they have growing demands for water. So this is when it's coming. It's already there. Because of the drought and the other issues going on there, there's already a scarcity. And when you don't have enough for everybody, having a means, at least an economic optimization model, at least helps you make decisions on how best to use that water. And then climate variability. Obviously, this is a continuing problem, and we're seeing the effects of it over in East Africa right now. So, I mean, basically what an optimization model is, right? You're maximizing or minimizing objectives by systematically choosing input values. And again, we would get those from them. They're going to be locally derived input values, and allow them to move forward and see what the best choice is. If you want to distribute this water and meet a lot of different needs, you've got a tool now that's going to help you be able to do that. Then the next step really is everything that we do, we want to make sure that they can continue to do when we're gone. Initially, the idea was to come in and train a number of folks at the Ministry of Water and some people at the county, but we had a better idea, which was there's two regional entities in Nairobi, ICPAC and the Regional Center for Mapping, that they do training right now. And so what we've done is we're working with them to train their trainers. So we're running all the training programs at these two facilities, so that not only are the people from the agencies being trained, but the trainers at these regional facilities are being trained, so they can continue the work as trainers as we move forward. So it won't be just, a half a dozen or a dozen people getting the training. There'll be these two institutions getting the training, and that they can continue to do the training once we're gone. So the next step beyond this new area that we're moving in would be to have the locals start to do this work themselves with us, sitting alongside them to see, if they have any questions and stuff. But eventually they're going to take this work on themselves and continue it on their own. So they've been trained so far. We go over, usually it's 6 2-week sessions on the use of remote sense data, how to pull it down, how to stitch it all together, how to interpret it. And then Wayne's been doing the training on the hydrogeologic, how you develop a conceptual model, how you can refine that over time as you get more data. You've got the optimization model going on. That training is going to be coming up pretty soon too. We've had a lot of fits and starts with this because of COVID, with some other issues in Kenya. We haven't had a nice, easy schedule. We've had large blocks of time where we couldn't go over there for various reasons. So we're trying to get back on schedule with this and get all of this put together. But in the long run, the idea is that they can put together a national water strategy that's based on science, it's based on data, that they understand what's going on out in the systems, and they have a means and have the tools to go through and make some decisions. So the more we can give them decision support tools and show them how to use it, we think in the long run, they've got a better chance of coming up with a sustainable national water strategy. So just a couple of pictures of the training that's been going on. We've got, again, we have some good access to the training facilities. We've got both ICPAC and the Regional Center for Mapping, letting us use in their facilities. This is Tom Mack was teaching them how to use this passive seismic instrument out in the field to be able to map some of the sediments. And then this is, again, us getting together. We had a big launch meeting there, I guess about a couple of years ago now. That's Martin Malengo, myself. They wanted to announce the project and get everybody on board with it. And that's worked out pretty well. So again, basically, we looked at maps, using remote sensing. We were looking at potential groundwater in the upper 200 and seeing where we thought we could find that, and then using basically the same technology to look at recharge zones. Where do we think the recharge zones are for these aquifers, so that, again, they can be protected and they can understand where they're located. And the hope is that, we'd bring some stability and some hope to it, and that they have right now. It's, it's difficult to go over there and watch people walking 2 miles to a dirty river to pull up some water and bring it back to their village and not have access to clean water. We're just so used to it here to see some of the things that we've seen over there and understand how really important this project could be for them in the long run. And in addition to that, you might make some friends. So I had a chance to, I asked these ladies if they'd make my wife jealous, and they were more than willing to jump around me and take a picture, and we had a lot of fun together. Very good people very happy, you know, looking at what they have access to there and understanding what they're dealing with. It's really impressive to see how upbeat and you know, just happy. I mean, really just happy people. This is the Turkana tribe. We were up in northern Turkana. So that's it for the presentation. If you have any questions, I'm certainly here to answer them. We can go back and look at some of the slides if that's what you want to do, or I can just, you know, try to answer questions on the fly. It's up to you.
Thanks a lot, Rick. That was fantastic and really impressive that you can increase the success rate for drilling from like 20 to 30% to 80 to 90% by using these approaches. You mentioned that you, in the top 200 meters, you looked at the different units. And so I guess the remote sensing is used mainly to map the paleo valleys, is it? Or, you know, is that where you have the highest success?
Yeah, I mean, basically looking at the topography and then trying to look from the radar data, whether or not we can understand something about the material we see. And Pat has been has done quite a bit of work like this out in the desert Southwest, and has a way of looking at it and understanding where he thinks that the sediments might be conducive to infiltration. But again, the topographic is going to tell us basically where we think the water is going. We do have access to some global rainfall data and to get some ideas on where we think water is coming in. You know, when I was there, actually for this meeting, when I'm the picture from, we had a downpour while we were there, and all those local streams just, you know, fill up very quickly, but then they drain out very quickly. So looking around those streams, I mean, it just made sense. That's where you're going to find the water. And again, if you can look at the vegetation, and that's surviving through a dry period, so taking the Landsat photos during the driest periods and looking for that vegetation, combining that information, as we say, we're trying to pull pieces of data together and different information, and through a convergence of evidence, coming up with the idea of where the best potential is for groundwater.
Great. And how deep typically are the wells out there? I mean,
it's everything from hand pumped wells. There's a couple of deep wells. This is where, again, the frustration of trying to get those well completion reports. And, you know, we thought we had access to a really good data set there with 500 well completion reports in the 2 counties, but they just weren't that good. So that's been one of the frustrations, and we've got them looking at that to clean that up and to see whether or not they can improve the accuracy of some of those completion reports, so that they get more data and they can understand it.
Rick, this is
anybody else have a question?
Yeah, Rick, this is Brian Hunt. Yeah, the poor data from well drilling logs, I think that's a global phenomenon. We have that here in Texas for sure. So that speaks maybe to that industry a little bit. I had a question about, you know, some of the remote sensing, and if y'all discussed or have access to LiDAR, for example. You're talking about, you know, how critical the topography is, and if that's even, you know, in the realm of possibility of using some of that for your mapping.
So far, no. Again, we were trying to use what's readily available now. I mean, LiDAR technology, I know, is being used in a lot of places. I think the topography, you know, it's good enough based on the data we have. And I would think the LiDAR would be what you'd be using to maybe refine that. Is that what you're thinking, the LiDAR?
Yeah, well, it kind of feeds into my next question, was more about structure in the groundwater system. I mean, you know, it looks like most of the mapping is likely lithologic in nature, but is there some attempt to try and, you know, find these lineaments and deeper structures or things that help control, you know, groundwater flow and
yeah, you know, there was definitely in the review of the remote sensing, looking for lineaments, you know, things that we could see on the surface that would tell us something about the subsurface and see whether or not that really helped. And again, I'd have to get Pat involved in that, but I didn't think it really helped us that much in this case. But it is something. He looked at quite a few different data sets and tried to narrow it down as to what we would thought really were the ones that were going to give us the best information, at least in this study area, and that may change in the next study area.
Yeah, you're pretty close to the rift, isn't that right?
Yep.
So there should be quite a bit of fracturing and faulting.
Yep.
And another, I guess, question I had just generally in Kenya or parts of Africa, what is the governance of groundwater? You know, like the biggest struggle we have in Texas is that it's a private property right. You know, that sort of perspective of it's not a global or a common pool resource. What is the either cultural or legal framework there for groundwater in either Africa or Kenya?
I would say at this point, it's under development. I think because of this devolving of government functions from the federal to the county level, this is why, again, I get back to trying to understand the roles and responsibilities, even just taking water levels. Who's responsible for going out and taking routine water levels? Are you going to do that as an agency, or are you going to require that of the people that you're permitting to go out and take it? I mean, typically, I'm used to, again, from what we did in New Jersey was if you got an allocation permit, you had the responsibility to take water level measurements. You had the responsibility to give us all the well completion reports and put that responsibility on them. I don't think they have the regulatory program in place to be able to do that right now. I think it's considered a shared resource, you know, but at the same time, there's so many different people out drilling. I'm not sure that they know where all the drilling is going on.
Jennifer, can you? Oh, that's good.
Hey, can I ask a question?
Yeah.
We interrupted some of the conversation. So Rick, thanks for your talk. I have a couple questions. And first of all, so after the wells are drilled, is there a program for, I'm assuming that these are, you mentioned a combination of sort of mechanized, like, you know, submersible pumps as well as hand crank, you know, hand pumps. Is there a maintenance in order to drill the well in a particular village or in a particular region? Is there some agreement with the local authorities to maintain the wells after it's drilled? So that's the first question. The second is how are you dealing with water quality? I mean, it's obviously more than just wet well percent. And water quality tends to be a very big deal. I did work similar to this up in Ghana and Burkina Faso, and you know they have a lot of fluoride issues. So this is a really huge deal, is not just getting wet well, but actually getting water that's potable.
Yeah, water quality was not a part of this initial project, but that's one of the things that we've talked to them about now, and they're interested in starting to go out and doing water quality sampling. And this is where I talked to Bridget about trying to increase the capacity of the laboratories there. They don't seem to have, they have to send their water samples out. They send them to Morocco to get analyzed. So they really don't have that. We did bring some equipment to show them how to do some field parameters. And again, I don't know who is supposed to be responsible for that. It's just not clear. There was some water user groups that they've put together at the local level with the hopes of trying to get them to have some ownership over the facility once it's put in. But that has been a concern, is maintaining these wells. And this is why these vibration meters are being put in by the folks at the University of Colorado, so that when the well stops operating, somebody knows about it and can go out and do something about it. But that tends to have been a problem, I think, is that they're not maintained long term.
Yeah.
And that is an issue. So again, that I don't know, to be honest with you. I don't know who's responsible for it.
So the way that we handled that in Ghana was that there was a very small fee to use the water, and that and then that fee went into the maintenance of the well, as well as a person who was sort of the well tender. And so we actually built capacity in how to maintain, the hand pumps and all the rest of the infrastructure that was needed to do that. I don't know if you're familiar with, there's a research institute out in Nevada. I'm sure Wayne is quite familiar with them, but they built a water quality testing program for Ghana and helped them to develop it. And they had, lab certification and standards and things like that. And that might be a way of building that capacity in Kenya.
Yeah, like I said, we're going to be bringing in some USGS folks that have done that for us, and just on techniques, sampling techniques, and then also all the way through on analyzing the results. And they really haven't done that here. And there's some geogenic, stuff in the ground there that is causing high chlorides. There's fluorides. There's a bunch of things that limit how it can be used and what kind of treatment they're going to need in order to make it potable. In some cases, they can use it for agriculture, but it's really not used for potable purposes. So that's another area that they have really not spent a lot of time on, and this project really did not focus on it at this point. We're going to see whether or not in the next study area they want to get more involved with the water quality sampling.
Okay, thank you.
Yep.
Michael, we tried to connect with your Nevada folks on this, remember recently?
Oh, yeah. I mean, that was a big deal. I mean, in terms of E. coli, fecal coliform, that was the first step. Make sure that there's, that there's not, contamination through the annular space, ponded water right at the wellhead. I mean, that's always a problem because the cattle basically hang out where the water is.
Yep.
And then you have a short circuit right into the wellbore.
Yeah. Well, I think this is why they're interested in getting some help too on well design, because I'm not sure what they do as far as the annulus and whether or not they're sealing it up and how they do gravel packs and how they develop the well.
I mean, the West Africa Water Initiative really developed a lot of best practices. That was Burkina Faso, Mali, Ghana, and elsewhere, particularly in the rural areas in the north. That might be quite useful. Take a look at that.
I think there's a lot of good information out there, and we're going to try and pull it together and then do some hands-on training there.
Yep.
Hopefully that'll help. So it's growing. The project's growing. Every time we go, they seem to want more help. And as I say, I think that's a good sign, at least understanding that they need the help and focusing on what they need.
Yeah.
And so hopefully as we move forward, we'll be able to help them with that.
Great.
So, Rick, sort of following up on the overall goal is sustainability, and it looks like y'all are kind of it's really in the mapping it, trying to understand what's there, develop conceptual models. It's more about availability at this point.
Yes.
But eventually, when you get to the sustainable portion and however that's defined there, are there models being developed, like ModFlow type models, or is that what you were talking about, some of these models before? It could be that tool that they're then using because there's an agricultural center next to this, and so they may need to run those sort of things. Where are you in some of those in that stage of progression?
I think we don't have the data and the understanding to do numerical models there. The conceptual model was at least to get started. And again, showing them how, again, as you collect more information and you do get that data, how you can eventually turn that into a numerical model and use it. Again, who's going to run it and who's going to be responsible for it? I don't know. I don't know if that's going to be the federals or that's going to be at the state or the county level. These are the things that they're still going to have to work out themselves. Before we focus on models, and it's just my own senses, let's get data first. Let's get what, if you're taking regular water level measurements, that's a big step. If they keep declining, obviously you're pumping more than you should, and if you're not understanding that, the model's not really going to help you. They're not at that stage yet. But getting into some routine water level measurements is going to be important. And now there's some talk about maybe putting out some, remotely sensed sensors so that they don't have to be running out and looking at it. Some of these areas they're dangerous to go to. When we had the training just recently to show them how to use the GWENS units, the handheld units, to show them where they are relative to the map, we weren't allowed to go into either one of the two counties that we had the study area. The regional safety officer in Kenya wouldn't let us go there because of some of the situations going on there. So there's a lot of different challenges that we don't necessarily deal with here that can slow you down, and you can't get to everything that you'd like to get to. And it's going to maybe take a little while for some of these things to get sorted out. But they've had some security issues there that have prevented us from getting out to where we'd like to do. And I just heard back from the folks from the British Geological Survey who just went over there, and they had the same problem. Their embassy would not let them go into certain areas because of concerns with the violence that's going on. So it's a challenge. It's a challenge. Our area in Ethiopia that we started working is on the Somali border. And apparently there really isn't a border. I mean, it just kind of goes back and forth, and that's, our folks that went there it was a little touch and go too. So getting out into the field and getting the right data and getting all that is really the next step. They've really got to get into routine data collection before they want to get into doing any numerical models and getting into that type of the next level of what they're going to need. At least that's the way I think it's going to have to go. Because again, if you don't have data, that your models are not going to be able to tell you anything, right?
Yeah.
Yeah.
I totally agree. The data in the conceptual model are paramount. So
Yeah.
would you with the goal being sustainability, would you say that really it's about water supply is the key definition of sustainability and going forward, not necessarily agricultural, or where does that sort of move depending on where you are?
Well, again, that's their decisions, and that's why with the optimization model, the economic optimization model, depending on where they are, what part of the county they're in, or what part of the country, those parameters might be different. Agriculture may be more important in some areas than water supply. So they have a tool now that they can go in and say, okay, if we want to use so much for agriculture, what is it going to mean to the aquifer? What is it going to mean to the amount of water that's left over for water supply? And be able to look at that and make some, again, these are decision support tools that hopefully, once they get to use them and understand them, that'll help them make better decisions out there. But I think they're a ways off from getting to that point yet. Again, let's get basic data collected. Let's understand that. And then I think they can move forward with it, because at some point you've got to tell people they can't pump, or they can't pump as much as that they want to pump. You're going to put some limitations on that. And that's you have to have a pretty strong regulatory program that you can go out and enforce those things. And if you don't know what people are pumping, where they're pumping it, I keep saying, if you're trying to maintain a bank account, you don't know how many checkbooks there are out there, who's writing the checks and how much they're writing them out for, you're not going to be able to do that. And that's the case here. You've got to understand have a good inventory of all the wells in the area, understand how much water is coming out of those wells, and then that gives you an idea of where you're heading. And they're just not there yet.
So Alex Sun has a question in chat, and then Justin Thompson has a question. So Alex, do you want to ask your question, or do you just want me to read it out?
Yeah, sure. I can ask it. Probably I missed the numbers during your talk, but can you tell us the typical GPM of the wells that you drill, like the flow rate, I guess?
How much they can produce, gallons per minute, Rick? What's typical?
No, I don't have that information, honestly, because they don't have that information. This is where water use information and pump tests would be very important. Obviously, I hear that they do some pump tests, but again, trying to get that information, it's very hard to get some of these agencies to share data.
Okay.
It's very interesting when we were talking about trying to get rainfall data. The Ministry of Water there, if they want rainfall data from their meteorological agency there, they have to buy it from them, even though they're in the same, right? This is just not something we're used to here. Our data in the United States, USGS, Weather Service, we all put it out. It's available to the public. Not a lot of data sharing. And that's just a cultural thing that I think they're just going to have to get past and understand that they've got to work together if they're going to do this. So getting pump capacities, that'd be great. We were not able to do that. And so the total.
But I think maybe you could, some of the hand pumps would be very low capacity, Alex, and then some of the deeper wells would be higher capacity. And then you have another part of your question, Alex. The remote sensing.
I was mainly thinking now that GS has drilled a number of wells, but in terms of like predicting your next drilling target, do you have like a workflow or procedure to rank which information tends to be more useful in terms of identifying successful drilling target location?
Okay, we do not do any well drilling. Okay, we're not drilling wells. We're putting together the map so that the ministry, which does some drilling, and some of the NGOs and some of the counties can go out and do the well drilling. We don't do the well drilling ourselves. So this was really to develop the maps. The next step, I think, is they want to, geophysics is going to be next. Now that you have these maps, you can focus your geophysical evaluations to go out and say, okay, this is what the information we have indicates where we think groundwater is going to be, high potential. But this is where bringing John Lane in and some folks to be able to do some geophysics, whether it's borehole geophysics or all the various other tools that they have, to be able to maybe refine this a little better, make sure that before they start drilling that they know that there is water there, or there's a better chance of putting water there. But we're not doing the drilling at all.
Yeah, I guess my question was like, you already have the remotely sensed maps. Can you put the existing well locations on top of the, or overlay that on your maps and see, like, which information tends to be more useful, right? Because you already have the locations, even though you didn't do the drilling, right? So I guess that's what my question was about.
Yeah, as I said earlier, we had access to 500 well completion reports. One of the biggest problems was the locational information. So
It's not public.
It's not, well, it wasn't accurate. You know, if you plotted it up, some of them were in Tanzania, some of them were in the middle of Lake Turkana, some of them were, so there really isn't, let me be careful, but the review process of when these completion reports come in doesn't seem to exist. It seems that they get filed. Nobody really looks at it in detail to make sure that it's accurate before they accept it, and send it back out to say, hey, this isn't complete. It's not a well completion report. It's a piece of paper that has some numbers on it, but only 80 of the completion reports really were used in the study. The other 420 just couldn't be used. So we didn't really have an idea of where all the wells were. And that's, that would be the next step, obviously, would be to go out and see whether or not, there may be areas where they've got wells drilled and there's water, and our maps say that we don't think there's water there, so that's a possibility. So that would be the next step. Again, it's a process. They've got to continue to collect data. We've asked them to try and improve the locational information on these completion reports and see how that changes what you see out there. But when you're dealing with an incomplete data set, it makes it difficult.
Yeah, I heard some studies where they do crowdsourcing. Just in case the local people, they may share something online or through the, if you do a crowdsourcing, by pictures like someone, taking water from a certain well, then maybe that can be a potential approach. I don't know.
Yeah, no, I agree. Early on, what we tried to find is the other programs that are going on in this area, and whether people who had local knowledge would be able to tell us, hey, there is a well in this village, and they do use it 3 times a year, 6 months of the year, or they use it continuously, and try to get some local information, as you're saying, from the people who are out there. And there's people in the WASH program and other programs that are out in these villages fairly regularly, and trying to get them to tell us what they see and where they see wells located. So again, a process, trying to get them to start thinking about that. While you're out there, try to get a location. Can you get a GPS location on that well, so that now we know where it is and get an understanding of how often it's used? And that would bring more information, that which would allow us, again, to both refine the maps and refine the model.
Thanks,
Rick,
Alex. Justin, thanks for your patience. Go ahead.
Yeah, no problem. Really interesting talk. I have been doing, I've done nonprofit work in Kenya and Tanzania for years, so I'm, keenly familiar with a lot of the struggles that you're describing. And I really applaud the effort, right? It's in just in my experience, the lack of data and information on these groundwater resources is stunning, and a real problem, right? A lot of these NGOs and even community groups and whatnot, they wind up basically just wildcatting. Yeah. And it's heartbreaking to see some of these situations where a community has pulled together and they've gone through all this effort to work with an NGO or a government entity to drill a well, and it comes up dry because nobody knew, right? So I just, it's great work. I'm really fascinated by it. I think it's desperately needed. I guess if I have a question, it may be sort of unfair, or you might not be able to answer it based on kind of what I heard you saying earlier about, sort of a lack of clarity and understanding of, responsibility and, kind of who takes lead on what elements of this. But my real key question would be about, how do you envision this kind of information, this informational product getting to the people that really, would need it, right? Where the rubber meets the road. Everybody from the communities to the well drillers, right? I mean, do you have a vision for that? I mean, or is it kind of murky at this point?
Well, the idea was to turn over the maps to the Ministry of Water and let them be the ones that distribute it. So that's where it is at this point. I do have some concerns since they haven't been very good at sharing data. They might not be very good at sharing the maps. So we have talked to USAID about posting the maps, getting them up on a website so that people can pull them down and use them, and it doesn't matter who it is. But there's some political issues there that we probably don't fully understand at this point. And so at this point, the ministry is going to be in charge of the maps. But I think over time, the hope is that they'll be widely distributed, and whoever's out there, whether it's Global Water or Water Millennium or whoever's out there trying to drill can use them, because it's very expensive. I mean, we hear numbers of like $500 a meter to drill out there, and just trying to get that. It's just we're wasting money.
Right.
That money could be better utilized and focused in a way that makes sure that they get the best bang for their buck. And again, there's a lot of local and regional, or I should say federal issues going on that just we're not really involved in at this point, these institutional issues. I have a background in it because of my time at the state and running these programs, so I have opinions on it, but I got to be careful.
Well, I can certainly respect that. I mean, that was kind of my thinking, it was just that there's often this, kind of disconnect between the what little data there is available, right? And then, like I said, the folks, the real stakeholders and people who need to use it actually getting their hands on it. And that's, I would hate to see, a project like this kind of fall into that trap as well. I would hope that, it would be a resource that people could actually really easily get to and understand and apply.
Yeah. Well, I think we come with it, again, back here in the States, we share as much information as we can. I think most agencies do, whether it's a county, state, federal agency. We try to get it out there so that more and more people can access it. And that's just not the case, not just here, but I mean, in a lot of countries. We went through this in India, where it's considered a national security issue. They will not release information, even on stream flow discharges and stuff, and so it's just a totally different atmosphere as far as what you do with data and information and how it's used or not used.
Right.
Yeah.
Right.
It's just interesting. And even if they do get go ahead.
Yeah, I think, Rick, there's, thanks, Justin. There's one last question from John on the chat. John, do you want to ask your question? John, I mean, the question in the chat was, have you interfaced with the Turkana Basin Institute initiated by Richard Leakey? And they have a strong community-based approach. And John has worked in Turkana County since 2008 on geology and paleontology. Have you interfaced with them at all, Rick?
No, we have not. We had people from Turkana come down to do the training. They came to Nairobi and they sent 2 people to each one of the training sessions. We didn't have a lot of interaction with the folks up in Turkana. Again, we had some restrictions on being able to get up there. So no, there's a lot of institutes, a lot of different folks there, and the more we can find out about them and the more we can try to, work with them, yeah, it'd be great to be able to find out what's going on there. But so far, no, not any.
Rick, can you
Go ahead,
hear
John.
me?
I can hear you, John. Yep.
Yes.
Oh, can you hear me? Yeah. No,
Yep.
I just wanted to mention that, when I first started working in Turkana, that the basin was just getting off, the institute was just getting off the ground, and they have an incredibly strong network now. So I was in Turkana this past June, everything went fine, but their interface with the local communities, and it has a development aspect to it, is just great. That they have lots of resources there. It on the one hand, it made my work a lot easier in that we didn't have to go in individually and negotiate with the different villages and tribal groups to be able to access these areas. But if you just check out their website, I think the woman who is running the development aspect, her name is Acacia. She's a niece of Richard Leakey. I don't remember her last name, but the community aspect is just great. And so I'm sure that they would be able to get you access through Turkana if you wanted to extend the work up into the south of Lodwar. But they're a really great group.
Yeah,
And also, I was going to say that there was an earlier question I heard about LIDAR that Louise Leakey, who is Richard's daughter, was going to fly LIDAR for us. And I don't know if that flight has been completed yet or not, but they were flying limited areas where there were paleontological sites. So there is LIDAR available for that portion, or should be available for that portion of Turkana County. But I think is that a bit north of where you're working?
Well, we were Lodwar South. We were basically from Lodwar South is where we were working. At least on the remote sensing, because again, RTI had done the northern part of the county. The hydrogeology, we did the whole county. But just from the mapping standpoint, we were focused on the southern half of the county because they have maps for the northern part of the county that RTI had put together, and they didn't want to duplicate that. What's the name of that institute again?
Turkana Basin Institute.
Okay, if you can send me a link to it, I'd appreciate that.
Sure.
there-
And do you have access to the oil well data from that area?
Yes,
From the Lokachar?
we got a couple of well completion reports from them. There was an agreement between the Ministry of Water and the Ministry of Energy, and I think we got 5 or 6 pretty decent well completion reports there. They were willing to give us the top 500 or 600 meters, see part of the system that they're not really interested in. Their proprietary information is the deep stuff. So we did get a couple, but I think it was only about 5 or 6 well completion reports from the industry, but very professionally done. And they were probably some of the best ones we got, if they probably were the best ones we got.
Well,
There's
I
a
think we're
grad student I
close
can
to,
put you in contact with from.
Go ahead, John.
yeah,
So I was just going to
Thanks,
say, I
John.
can put you in contact with a grad student from Rutgers who's working a lot of those oil data. And he might have some interesting information for you.
Okay, that'd be great. Yeah.
super. So thanks so much, Rick. That was a wonderful presentation. And thanks everybody for joining us this morning. And we recorded the presentation, so it's going to be available online for people to access who couldn't attend. So hope everybody has a good weekend, and we'll be in touch, Rick. Take
Okay,
care.
yeah, we'll set up a call. Like I said, I'm gone for the next 2 weeks, but
Yes.
when I get back, we'll set up a call and talk. Okay,
Right, sounds wonderful. Thank you.
Great.
Bye, everybody.
thank you for your time.
Thank y'all. Bye-bye.